Right, hello. Can anyone hear me there? Right, we should be able to hear me. Oh, yes, people saying yes now. Excellent. Right, I'll just wait a couple more minutes. Okay, so I'll just wait, give everyone a couple of minutes just to log in, and then we'll make a start. Let me know if there's any issues with video or sound. Right, we'll make a start. Firstly, apologies for all the technical difficulties and the saga of my internet working, then not working, then working again. But we can make a start now, so that's all good. So the first thing I'm going to look at is this past paper question that I posted earlier. Now, this is going to use product moment correlation coefficient. So this question here, hopefully you've had a look at it, but if not, you can hopefully read it now. And the first question is just simply why a linear regression model based on the data you've got there is unreliable. So when you look at the data that you've got there, the temperatures you've got, well, the maximum temperature you've got there is 19.3. So if you want to use 24 degrees, then that is outside of the range of your data. So that is extrapolation, meaning that value would be unreliable. And then for part B, state what is measured by the product moment correlation coefficient. And this is just that there is linear association between W and T. Okay, so there's other relationships such as you can have exponential, but for this particular question, we are looking at the linear association. So if you plot this on a graph, you would see a straight line. For our second part, so this is where the actual hypothesis testing comes in. So a little reminder on what to do with correlation coefficient. And they've got their value of R to be 0.609. So this is something you can do on your calculator, but this has already been calculated for us in the question. So for the 5% significance level, okay, so this is what we do for our hypothesis test. So when we are doing this, we need to write our hypotheses. So the first one, just give me a second. So first off, we write our null hypothesis, and when we're looking at product moment correlation coefficient, that is just simply that there is no correlation. And the alternative hypothesis is that there will be a correlation. So for our hypotheses, and this is what we'll always write with a product moment correlation question. When we've got hypotheses, we write no correlation, and then we write rho, the Greek letter, does not equal 0. Now, if we're testing for the 5% significance level, what we need to do is find our critical value. So this is where you'd need to use the table that you get in your formula book, and this is where n would be 9. So we look at a sample size of n equals 9, and then because we're looking at the 5% significance level, we'd look at our critical value here. So we'd write down that our critical value is going to be 0.5822. And then what we do is we compare this to the value of R that we get from our sample. So what this means is this 0.5822, if we have a value that's greater than that, that means the correlation is strong enough. So we can conclude that there is a correlation, there is a linear association between the two variables. So in this particular case, our 0.609 is greater than 0.5822. So therefore, we can say that there is evidence of a correlation, and then we just refer to the context of the question. So we are looking at temperature and wind speed. So we say there is evidence of a correlation between temperature and wind speed. And then the final question, it does involve the large data set. So then it goes on to say, using the same 9 days, the location from the large data set gave the mean temperature as 27.2 and the mean wind speed as 3.5. Using your knowledge of the large data set suggests giving your reason location that gives rise to these statistics. So firstly, we note that it's in July. Okay, so we're talking about July, and we've got a mean temperature of 27.2 and the mean wind speed is 3.5. So what this suggests is we've got quite a warm temperature but quite a low wind speed. Now, the fact that it's quite a high temperature will probably make us think that it's not in the UK. So then it takes us to some of our abroad places. So these are the places that are non-UK. Also, what we can rule out is Perth. Now, we can rule out Perth because Perth is in Australia, but in July it is winter for Australia. So whilst it'll be summer in the UK, Jacksonville and Beijing, then it is going to be cold, slightly colder in Perth at that time. Still relatively warm compared to the UK, but the fact that it's quite a high temperature would suggest that it is going to be either Jacksonville or Beijing in terms of the temperature, and then the low wind speed would then suggest that it is Beijing. And the reason why is Jacksonville, as you can see there, is on the coast, so we'd expect Jacksonville to be quite windy. Beijing's not quite on the coast, so it makes sense that Beijing will be the place there. So that was just a starter question, and what I'll do is I'll later today put up a new starter question for you to do tomorrow. But for now, we're going to get into the hypothesis testing for normal distribution. So you've just seen an example there of doing that with product moment correlation coefficient. And now what we're going to do is look at doing that, but with the normal distribution instead. Now this works a little bit differently with the normal distribution, and that's because we are now looking at our continuous data, and we don't need to use a table of values to find the critical values. We can just use our calculator here. So when we are looking at the hypothesis testing with normal distribution, we are looking at taking a sample mean and seeing how likely it is that we could attain that value. There is going to be a slightly different way that we do this tomorrow, and we look at critical regions. But at the moment, we're going to be looking at finding a sample mean and then seeing how probable that is. Now, what we have to be careful with our sample mean is that the variance now changes. So up to this point, when we've been doing our variance, we've been using sigma squared. But now, with a sample mean, we need to do sigma squared over n. Now, as you can imagine, the more values that you take, the larger your sample size is, the more confident you can be that the sample mean is close to what the actual mean is. Okay, so remember, we've got a big population, but we're just taking a sample mean, so we're not taking every single piece of data in, but the larger that sample is, the closer we'd expect it to be to the actual mean. Now, in terms of that sample variance, the more values we take, the lower that's going to make the variance. So that's where the divide by n comes in. So, in terms of our hypothesis test, with the sample, when we're doing this for normal distribution, our null hypothesis is that the mean is just what we believe it to be to begin with. If we are looking at the standard values or our z values, then our mean would just simply be 0. Now, our alternative hypothesis is going to be that the mean is actually greater than that, or the mean is less than that value. And if it's a two-tailed test, it's just going to be that the mean doesn't equal that value at all. It doesn't equal that value at all. So it's either greater than or it's less than. Now, what we do is we reject H0 if our test statistic lies in the critical region. So it's so improbable that we have to reject the null hypothesis that the mean is what we believe to be true at the beginning, and actually it is something different. So what I'm going to do is I'm just going to go straight into an example, because there's a lot of explanation there, and I think it just makes sense if we just go straight into the example and then we go forward from there. So we've got a company sells fruit juice in cartons. The amount of juice in a carton has a normal distribution with a standard deviation of 3 millilitres. The company claims that the mean amount of juice per carton is 60 millilitres. A trading inspector has received complaints that the company is overestimating the mean amount of juice per carton, and he wishes to investigate this. So the key thing here is we're overestimating the mean. So firstly, what we always need to do with normal distribution, when we're doing the hypothesis testing, is we start off by writing what the mean is to begin with. Okay, and that's that the amount of juice per carton is 60 millilitres. So we start off by saying the null hypothesis is mu is going to be 60. Then the alternative hypothesis is that because we're overestimating the mean, that the mean is going to be less than 60. So this is really important that we write our hypotheses to begin with. So always our null hypothesis will be H0 mean, so we put mu, equals, and then whatever the mean is. So in this case, the mean is believed to be 60 at the start. Because we're overestimating the mean, or the claim is that we're overestimating the mean, they are suggesting that the mean is actually less than this. Okay, so they think saying 60, that's too much, so they actually think that the mean is less than that. So we'd put mu is less than 60. So the inspector takes a random sample of 16 cartons and finds that the mean amount of juice per carton is 59.1 millilitres. Using a 5% level of significance and stating your hypothesis clearly, test whether or not there is evidence to uphold this complaint. So firstly, what we need to do is work out our sample variance, and be careful because this is different than what it normally is. So for the sample variance, we're just going to write that it's sigma squared over n. So just be careful with when we're doing the hypothesis test, we need to do sigma squared, the variance, divided by the number in our sample. So the variance, we are told, so we told this earlier, that the standard deviation is 3. So the variance will be 3 squared. Now normally, in normal distribution, we'd just use the 3 squared as our variance. But because this is a sample, you need to divide by the 16, because that's how much is in your sample. So we're doing 3 squared divided by 16. So that is our sample variance. So now we write down our distribution. Now there's a slight difference. Normally we'd just write x, but now we write x with a little line above it. And that's because we're now looking at our sample means. Okay, so we put there the mean as it is 60. So we put down the mean that we believe to be true to begin with. And then we want to put a sample variance, which is our 3 squared over 16. I'm going to highlight this, and everything I highlight here should always be part of your hypothesis test. Okay, so these are the things that you need to do to score the marks. Now, what I'm going to do next is draw a little diagram. So if we've got a mean of 60, we've got our sample variance of 3 squared over 16. And what we're testing is that in our sample, we find that the juice is actually 59.1. So that's clearly less than 60. But what we want to see is how significant is that? So what we're trying to do is work out what is the probability that the sample mean, what's the probability that our mean is actually, our sample mean could be less than 59.1. So if we really do have a mean of 60, what's the probability of when you take a sample of 16 that you actually get 59.1? So I then just do that on my calculator. So normal CD, and then we just get 0.1151. And then what I do is I compare that to the significance level. Okay, so I'm going to highlight that because that's part of what we need for the marks here. So my significance level is 5%. Now I can see that the probability that the sample mean could be 59.1 is 11.51%, or 0.1151. So this also is part of what I need for the marks. Typically it'll be sort of 6 or 7 marks for this. And then I can make my conclusion. So the probability is greater than 5%. So that's not enough to... Sorry, wait a second. That's not quite enough to reject my null hypothesis. So I'd just say accept H0 and say that there is insufficient evidence to suggest the mean amount of juice, and then we just copy in the context from the question. The mean amount of juice has been overestimated. Okay, and that is how we'd all get the marks. If we're going to just disrupt in the chat, can you please leave? Because there's a lot of people that will actually want to be trying to actually learn from this. So they might actually have questions. So you're just ruining it for other people. Right, so I'm just going to recap there. what we do. So firstly, we need to always put our hypotheses. So the null hypothesis is the mean is 60. The alternative hypothesis is that the mean would be less than 60. Write down your distribution. So we've got a mean of 60. Sample variance, we need to divide by n here, the number in our sample. Work out the probability that it would be less than 59.1. Okay, so what's the probability that it could be 59.1, which is what we get from our sample that we take, or less than that, and then go from there. And then we just make our conclusion at the end, so we say accept H0 and then go from there. And just make sure that you always put that context there at the end. So next example, the mean travel time for pupils who travel by bus is known to be 18.3 minutes. So first thing that we do is we're going to write H0 is 18.3. And then if we read on, a survey is carried out to determine whether the mean travel time to school by car is different from 18.3 minutes. Now, because we're talking about different, it means that the change could be happening in either direction. So we're either going to say the mean is not equal to 18.3. Okay, because we're looking at change in either direction. So it could either be, the mean could actually be greater than 18.3, or the mean could actually be less than 18.3. So this is important. We need to always make sure that we put our hypotheses before we continue. We also need to write the distribution. When we're talking about our hypothesis test, we're talking about sample, then we're going to put X with a little bar above it. And then I'm going to put my mean, which is 18.3. The mean is always what we start off with believing to be true. And our sample variance, so the variance, remember that's just standard deviation squared. The variance would be 8 squared, but then I need to divide it by n. And n in this case is 20 pupils, so I just divide by 20. So then we just get the following. Okay, so for sample variance, it's important that we do the variance divided by the number in the sample. It's a really important thing that you need to do. You're going to lose marks if you don't put that. Then we get told that in our sample, the mean travel time is found to be 22.4 minutes. So what we need to do is work out what is the probability that the mean is greater than 22.4. Okay, so if we've got a mean of 18.3 and this is our variance, what is the probability that we could get 22.4 or more? So we put that on our calculator, we use normal CD. And remember, when you do it on your calculator, you need to put in the standard deviation. So we put this on our calculator and we get 0.01095. And then this is our final answer. I then need to compare it with my significance level. Okay, so what I'm saying is the probability that of getting 22.4 or more is 0.01095, and that's what I get when I put that in on my calculator. So you might be wondering, well, why am I putting 5% there and not 10%? Because I'm told to carry this out at the 10% level of significance. And that's because when we've got what we call a two-tailed test, okay, so because we have the not equal sign, we've got a two-tailed test because we're looking at the change in either direction. So we're looking at a two-tailed test. When we have a two-tailed test, we halve the significance level. Okay, so we halve the significance level, and what we find is that the probability we get is less than 0.05. So what we then say is, because that is less than our significance level, it's highly improbable that if the mean truly is 18.3, we get a value of 22.4 or more. So then what we say is we reject H0 and would say there is sufficient evidence to suggest the mean travel time, because this is where we've got to make sure we put the context in. The mean travel time by car is greater than the bus. Okay, it doesn't need to be any sort of essay that you're writing here. It just needs to simply say if you reject H0 or not. So here we reject our null hypothesis. We reject the fact that the mean is 18.3. The mean clearly is we've got quite sufficient evidence to suggest that the mean actually is different. Okay, so it's in this case, sorry, I shouldn't put greater there. I should put different to the bus, because that's what we were looking at originally. Okay, so we just say different than the bus there at the end. And then finally, seems kind of a bit out of season this question, but a farmer grows Brussels sprouts. The diameter of sprouts in a particular batch measured in millimetres is normally distributed with mean of 28 and variance of 16. Sprouts that are between 24 millimetres and 33 millimetres in diameter are sold to a supermarket. Find the probability that the diameter of a randomly selected sprout will be within this range. Now, firstly, this is a past paper question from an old spec. I'm going to be a bit harsh here and change that to say that it should only be 2 marks. And the reason for this is that in the old spec, you'd have to use tables to get these probabilities. Now we can simply just put this in our calculator. So in this question, we've got x, which I'm going to call let x be the diameter of the sprouts. And then we've got a normal distribution with a mean of 28 and a variance of 16. Now this is just our overall data, so we are not looking at sample variance here. So this is just what we've been doing since the start of the normal distribution booklet and just got our data here as normal. So the probability that it's between 24 and 33, okay, that's what we're looking at. The probability it's in the range of 24 to 33 is going to be 0.7357. So we'll just be doing that there. So we just simply, we get that from normal CD on our calculator, lower limit 24, upper limit 33, and then mean of 28, and standard deviation, remember, of 4, not 16, variance 16, standard deviation is 4. For the second part, we've got a bit of information here. So the farmer also grows onions. The weight in kilograms of the onions is normally distributed with mean of 0.155 and variance of 0.005. He's trying out a new variety which he hopes will yield a higher mean weight. In order to test this, he takes a random sample of 25 onions of the new variety and finds that their total weight is 4.77 kilograms. You should assume that the weight in kilograms of the new variety is normally distributed with a variance of 0.005. Write down a suitable null and alternative hypothesis for the test in terms of mu. State the meaning of mu in this case. So firstly, we just need to write our null hypothesis. So that is going to be that the mean is what we believe to be true to begin with, and that is 0.155. That's just what's given to us in the question. And then we've got, we've then got our alternative hypothesis. Now, the alternative hypothesis is that he hopes it will yield a higher mean weight. So because you're looking at a higher mean weight, we want mu being greater than 0.155. So, one-tailed test in this case. Mu is the mean weight of the onions. Okay. So then our second part, we're actually going to carry out the test. So we need to write our distribution. So we put our mean, the mean that we believe to be true, which is 0.155, and then we write our sample variance. Now we're told the variance is 0.005, and our value of n is 25, so we need to divide by that 25. So then there's a little bit of difference in this question. In this question, I'm not told what the sample mean actually is. What I'm actually told is that the total weight is 4.77 kilograms. So this isn't actually my sample mean. The sample mean here is going to be the 4.77, the total weight divided by 25. So the average weight of one of the onions is 0.1908. Right, so the total weight is 4.77, there's 25 onions there altogether. So divide that and then you get 0.1908. So that's your sample mean. And to write the sample mean, if you remember from before, earlier in one of the earlier stats books, we wrote that X with a little line above it as so. So now what we need to do is work out what is the probability of finding a value that is greater than 0.1908. And we just put that in on our calculator. Remember to put the square root of 0.005 over 25. Okay, that will be your sample, your standard deviation, your sample standard deviation. And when we do that, we get 0.00568. Now, that is going to be your probability. So that's obviously quite a low probability. So if you're stating that the mean is 0.155, you've got the variance that's given there. Then we've got the following here. Okay, so we compare it to the 1% significance level. So that's going to be 0.00568. And then we're just going to state that because that's so insignificant, such a low probability, that we'd say reject H0 and would say there is sufficient evidence to suggest the new variety of onions yields a higher mean weight. Okay, so this has been something a little bit different. Unfortunately, there has been some people that have used this to some extent. People setting up fake accounts. What I think we'll do is next lesson we'll disable the chat. I think that's definitely the first thing that's going to happen. So apologies for that. Apologies for those of you that actually had proper questions. What we will do is if you do have any questions, I'll still be on Teams. So there's a few things, it's a little bit different obviously doing it in this format, so things that I might have not gone through in as much detail as I normally would have. So just in the lesson, that chance to ask questions. So please do ask if you do have any questions. But the key things to remember here: always write your hypotheses. Then always make sure that when you've got your sample variance, you divide your variance by n. So that's key as well. Work out your probability, and if it's less than your significance level, then you are going to reject H0. If it is greater than your significance level, you accept H0 in those cases. So let me know, I'll be on Teams, let me know if you've got any questions. We'll end the stream here. I'll be on tomorrow and we're going to look at critical regions. So this is going to be a kind of the same thing, but a different way of coming to your final answer. Okay, so I'll be on tomorrow at 11 o'clock and I'll see you then.